In this video, we're going to talk about solving quadratic equations using completing the square. Now, in general, if you can, you should try to factor a quadratic equation first to solve it. But some things are not factorable. They're prime, as we've learned. And the completing the square method is a way to solve quadratic equations that are prime, meaning that they're going to have irrational solutions. So, the way we're going to do this is we're going to try to get our quadratic equation into the form of something squared equaling a constant, because then we can use our square root property. So the way we're going to find this is we're going to have it factor into a perfect square trinomial, meaning that we're going to end up with a binomial squared when we factor it. So we have to find a perfect number to add to this part of our equation so that it will be factorable. And the way we're going to find that term is by using b divided by 2 squared. And that's going to give us that perfect term that when we add it to both sides, the left-hand side will be factorable. So the way we're going to do this is, again, get it into this form that I have here, meaning if there was a coefficient, you need to divide it away. Like this example down here, you're going to divide that 2 away. You're going to isolate the variable terms. So all I want is the x squared and the x on the left-hand side and the constant that is not the factorable term on the right-hand side. Then we're going to find that perfect value. So in this case, we use b. Remember, a is the x squared coefficient, b is the x term, and c is the constant. So here our b is 8. So I'm going to take 8 divided by 2 and then square it. 8 divided by 2 is 4, and 4 squared is 16. So that's the perfect amount. We're going to have our x squared plus 8x plus we're adding in 16. But whatever we do to one side of the equation, we have to do the exact same thing to the other side of the equation. Alright? We have to keep it equal. And now the left-hand side should be, when I factor it, a perfect binomial squared. So we want something that's going to multiply to 16 and add to 8. Well, 4 times 4 is 16, and 4 plus 4 is 8. These have to be the exact same value. That's how you're going to get that perfect square trinomial, and it's going to factor into the binomial squared. Alright, so if these don't match, then something went askew. So when I factor this, it factors into x plus 4 times x plus 4, right? X times x is the x squared. We'll have 4x plus 4x gives us the 8x, and 4 times 4 is the 16. Simplify the right-hand side. 1 plus 16 is 17. Now we're not going to leave it in this factored form, right? That's not really completely factored. To completely factor it, if I have something times itself, I'm going to write it as that quantity squared. That's completely factored. And that's the goal that we were trying to shoot for, was a quantity squared equaling a constant, because now we can use the square root property. We use the square root property, take the square root of both sides, don't forget our plus and minus. Square root of something squared is itself, and then we'll have plus or minus the square root of 17. That 17 is not factorable, it's not a perfect square, so we can't simplify that radical, but you should always be trying. If you can simplify, you should simplify. We still need to get x alone, so we subtract 4 from both sides, and x equals negative 4 plus or minus the square root of 17. And that's as far as we can go. Again, your homework might make you write it as the two separate solutions of negative 4 plus the square root of 17 and negative 4 minus the square root of 17. Okay, so make sure that you're writing out your answer however it wants you to write it. I would like you to try these two here on the right. I'll warn you, you will have fractions that you're going to have to deal with. Sometimes they're not always as neat and tidy as this one was. And on this one down here, you need to get rid of that 7, right? We just want the variable terms on the left-hand side, and you need to divide away this leading coefficient. We don't want anything next to the x when we try to complete the square. Let's see how you did. Let's start with the y squared minus 5y plus 2. Again, we're going to get rid of this 2. If you tried to factor it, you'd find that it's not factorable. So now I have y squared minus 5y equals negative 2. And we're going to find that perfect term that we can add to this part to make it factorable. And actually, I'm going to leave some room here. So we're going to be adding some perfect amount to make that factorable. And whatever we add to one side, we're also going to add to the other side. We're going to find that perfect amount using the b divided by 2 squared. We identify the b term as negative 5. Right? A is with the squared, b is with the first degree, and then c is the constant. So b over 2 squared. Negative 5 times negative 5 is positive 25, and 2 times 2 is 4. I warned you we were going to have fractions this time. We're just going to have to deal with it. 25 fourths and 25 fourths. Whatever we add to one side, same amount to the other side of the equation. Now the left-hand side is factorable, so we're going to factor it into our binomial squared. And my hint to you is it's always going to be that quantity simplified before you square it. So in this case it was a positive 4. So it was 4 times 4 gave us 16, and 4 plus 4 gave us 8. It's going to be negative 5 halves, right? If I want something that's going to multiply to 25 fourths and add to negative 5, that value is negative 5 halves and negative 5 halves, right? So negative 5 times negative 5 gives us the 25. 2 times 2 gives us the 4. It multiplies to positive 25 fourths. If we add it, we get negative 5 halves plus a negative 5 halves would be negative 10 halves, and negative 10 divided by 2 would be negative 5. So it's always this quantity in here before you square it. So I write it in my factored form. I'm going to skip the middle step here and just go right into y minus 5 halves, that quantity squared. Right? Because it would be y minus 5 halves times y minus 5 halves, which is that quantity squared. On the right hand side, I have to deal with this fraction here and add it to negative 2. So I'm going to put my negative 2 over 1, and then I need to have a common denominator to add. So 4, multiply here by 4 and by 4, and I'll have negative 8 fourths plus 25 fourths. That's going to simplify down to a positive 17 fourths. Now I have a quantity squared equaling a constant. I'm going to use the square root property. Take the square root of both sides. Don't forget your positive and negative solutions. Square root of something squared is itself. Y minus 5 halves on the left equaling, well, 17 is prime. I can't do anything with that, but I can use that division property or quotient property of square roots and take the square root of the denominator. So I'm going to leave the radical with the 17, can't simplify that, but the square root of 4 is 2. So splitting up this radical across the numerator and denominator. Okay? And then I need to get y alone, so I have to add 5/2 to both sides. Remember, this has a radical, this does not. They're not like terms. I can't really add them, but what I can do is write it as 5/2 plus or minus this, square root of 17/2. And because they have the same denominator, we can bring that together in one fraction if we want. So 5 plus or minus the square root of 17 all over 2. We can only do that because they have the same denominator here. And then again, your homework will probably ask you to split that up into 5 plus the square root of 17 over 2 and 5 minus the square root of 17 over 2. Alright, let's look at one more here. We've got 2x squared minus 2x plus 7 equaling 0. This is not going to be factorable, so we're going to complete the square. I'm going to get rid of this constant that is not working for me. I'll have 2x squared minus 2x equals negative 7. I also don't want that leading coefficient of 2, so we have to divide everything on both sides of the equation by 2. The left-hand side will be x squared minus x, and then I'm going to add some perfect value here, and then negative 7/2 plus whatever I've added to the left-hand side. Right? So I'm just leaving some space for that perfect value that I'm going to figure out using the b term. Alright, so got rid of my constant that didn't work. I've gotten rid of the leading coefficient. Now I can do my b over 2 squared. B in this case is negative 1. So I'll have negative 1 divided by 2 and square it. Negative 1 times negative 1 is positive 1. 2 times 2 is 4. So I'm going to add 1/4 to both sides of my equation. On the left-hand side, I have to factor it into that squared binomial. So I know I'll need an x. And then again, my tip to you was this quantity before you have squared it. So minus 1/2. I can check that, right? Negative 1/2 times negative 1/2 would give us the 1/4, that c term. And negative 1/2 plus negative 1/2 would be negative 2/2. And 2 divided by 2 is 1, and it'd give me negative 1. Alright, on the right-hand side here, I have to have a common denominator to add these. I'm going to multiply my fraction on the left by 2 to get that common denominator. And I'll have negative 14 fourths, that's 4, plus 1/4. And negative 14 plus 1 is negative 13 fourths. Now I've got my quantity squared equaling constant. I use my square root property. Take the square root of both sides. And square root of something squared is itself. So we end up with x minus 1/2 on the left. And don't forget your positive and negative solutions when you take that square root. We can't simplify everything, but we do know the square root of negative 1 is I. So I'm going to take out that square root of negative 1 as I. Square root of 13 is not simplifiable. You have to leave it alone. And the denominator square root of 4 is 2. Alright, still haven't quite isolated x. We need to add 1/2 to both sides. And x will equal 1/2 plus or minus I square root 13 divided by 2. They have the same denominator, so we can bring them together as 1 plus or minus I square root 13 all over 2. Again, your homework will probably make you split that up as 1 plus I square root 13 over 2 and 1 minus I square root 13 over 2. It may even have you write it in the form a plus bi. Again, just pay attention to the directions. And there you have it. So, completing the square. Get rid of the term that the constant term that's not working for the factoring. Divide out any coefficients in front of the leading term. Find your b over 2 squared. Add that to both sides of the equation. Factor into a square binomial. Simplify. Use the square root property. And then solve for x from there.